All right, here's a video just to kind of help you with homework 4. So in this problem right here, basically we have a fillet, we have a repeated reversal load of 400 newtons applied at C, and then we have a hole at D. Okay, and it gives you in section XX the dimensions and section YY. Okay, so the procedure, again, shear and moment diagrams. Just do a force up, which is what, 400 newtons, and you could do your shear and moment diagrams, which you can then find the moments at B, C, and D. Those are going to be the moments you're going to use later on for sigma max, sorry. Then you could use the design factor. Just use this equation right here. It's a shorter version for this type of loading. All right, so it's just Sn prime over sigma max. You could find Sn prime using the formula that we've been using, and one of these factors you're going to use, make sure you use the smaller cross section. Okay, I'll leave it at that. Sigma max for B and C, you're going to use this formula right here, KT times M over S. All right, where S again is your section modulus. You can find that out for a rectangle. We've been using that. KT though, for the section at B, again, you're going to have to find that. We've done that before. All right. However, at section C, it's 1. Okay. So, and then at D though, we have a hole. So sigma max actually equals KT times sigma nominal. And I want you to find that. I believe we did something like that in chapter 3. So check that out. Okay, there's a formula for that. That involves the moment. Okay. And the section modulus. So, and then once you're done, compare each N and see which one is higher. Okay. All right. Now, the second problem. Basically what you have, if you look over here to the left, you have this clamp support. Let me highlight this right here. Oh my god, that's not a highlight. Why didn't that work? Okay, this is clamped. Basically, it's like a bar that's being bent. Okay, and it's simple support. Okay, so you're clamped. So if you look here, I kind of drew it out. I'll do that. So you have this clamp bar and this load here where the pin is being applied downward, and then it's a simple support at the end. Okay. So what you need to do is, this is kind of like a deflection problem. So table A14-3, figure B, you can find equations for YB and MB, so the moment. Okay. Deflection and moment. The load is given by this equation here, which involves your deflection. Okay. I is BH cubed over 12. Okay. And then the other parameters you can find. And then sigma max and min, again, very similar to what we've been doing because it's bending. It's the moments over your section modulus, and it's BH squared over 6 for that. Okay. And then you can use the Goodman method to figure out everything else. Okay, so this particular problem I wanted to give to you because it's like a deflection problem, and it's just a way. Okay, let's remember what you did some in strengths. We have a load P that we need to find, which is based on this deflection. And then there's a moment equation that you can use, all right, that's based on the load, based on parameters, that's then used in these equations here. So once you find sigma max, sigma min, you can find your mean and your sigma A, and then you can go ahead and do what you need. Okay. You can assume KT is 1, CM is 1, CST is 1, and then you need to find CR and CS. Okay? So, I hope this gives you enough idea of the direction that you need to go for homework 4. Okay, thank you.